In this lesson, section 3.5 talks about the point-slope form of a line. So we've been used to working with the equation y equals mx plus b, and we're not always given all the information that we need in point-slope form, in a slope-intercept form, and so sometimes we're given partial information, so we can use that information and then derive the slope-intercept form. So sometimes you're just given a point and a slope. Sometimes you're given 2 points, and then you have to figure out the slope-intercept. So the equation is y minus y1 equals where you're going to put your slope in, x minus x1. So this is where you're given 1 point, and you put in the slope, and when you solve for y, it will give you your slope-intercept form. So let's look at one. Just jump right into it. So now I'm only given 2 points. Well, I want this in y equals mx plus b form. So I need 2 things. I need the slope first, and I need some other kind of point or something to give me the intercept. Neither one of these 2 points are intercepts. So otherwise it would be 0 comma something. If there was one of those, that would be really nice. I could just plug in that y value for b. But we're not given that. So the formula, and when I write it, I write everything that I need, and then I plug in what I'm given. So here is my slope, and here are my points, is my point. And here I'm given 2 points, and it makes no difference which point I use, because both of those points will be on the same line. So the first thing, I'm not given slope, so I have to figure out what the slope is. And I'm going to use my slope formula. So it's the change in the y, or the difference in the y's. So remember, it's the change in the y's over the change or the difference in the x's. So I'm going to take my y values, 5 and negative 3, and I'm going to subtract them. 5 minus a minus 3, all over the x's, which is 3, subtract 2. So a plus, a minus, and a minus is a plus, so I have 5 plus 3 over 1, which is 8 over 1, which is just simply 8. So now I have my 8. Now I need to pick a point, and I'm going to pick the first one. It makes no difference. So now I'm going to plug in 3 and 5. So my x always goes next to my x. So this is a positive 3, and this is a 5. If I wanted to use the other x, I would plug in 2 and negative 3 right there. And now I'm going to solve. So I'm going to drop the parentheses because I don't really need them. And now I'm going to distribute the 8 to the x and the 8 to the negative 3. 8 times negative 3 is negative 24. Now I just need to get y by itself, so I'm going to add 5 to both sides. So y equals 8x minus 19. Now I know the slope, and I know where it intersects the y axis, so I can easily graph. Okay, let's look at one that's a little bit more difficult because it has fractions in it. So now we're going to use 2 points, negative 4 and 6, and 9, 1. So again, I'm trying to put it in y equals mx plus b. So let's plug in what we know. So the formula, I'm given a point, and I'm trying to get it into point slope. So y minus, here's my slope, x minus. Put your minuses in there because you'll forget them, and then you'll start adding and doing all kinds of crazy things. So first we need to figure out the slope. So the slope is the y's, 6 minus 1. And you can go 1 minus 6 as long as you go backwards on the x's too. I always go left to right, then I don't get confused. Negative 4 minus 1. This is 5 over negative 5. Oh, I missed something. Hold on, let me back up. I made a boo-boo. This is not. This is, what did I do? -4 minus 9. There we go. It should be a -13. So here is my slope. And I'm going to use the first point. So it's y minus equals 5 -13 x minus. And now I'm going to use the point -4, 6. So my x goes next to my x. My y goes next to my y, and now I'm going to solve for y. So I can drop these parentheses, y minus 6, and I'm going to clean this up. So this is a plus. So I'm going to distribute this to the x, 5/13 minus, a positive and a negative make a negative. Oops, I got my x. And this is really 4/1, so 5 times 4 is 20. And -13 times 1 is 13. And negative times a positive is a negative. And now I need to add 6 to both sides. So this is y equals -5/13 x. And now I don't have a fraction here. And I need it to be in 13ths. So I'm going to change 6/1. I need something that needs to be over 13. Well, if I multiply the denominator here by 13 to get here, I need to multiply the numerator by 13 to get that. And 13 times 6, 78. So this fraction should be 78/13. So 78 minus 20 should be positive. 78 minus 20, 58/13. One that doesn't look so pretty, but that's okay. Okay, so let's briefly talk about standard form. So when an equation is in standard form, it looks a little different. The criteria for it to be in standard form, and we're going to use this in the rest of chapter 7 when we get to it. X and y must be on one side. There could be no fractions or decimals in the standard form. And x cannot be negative, so this leading term cannot be negative. So we're going to take one that's in slope-intercept form, and we're going to transform it into standard form. And again, this would be a great time to make a little note card and give yourself an example on how to change from slope-intercept to standard form and what the criteria are. So here you can see that x and y are not on the same side, so I need to move this over there. And I need to get rid of the fraction. So it makes no difference which order that you do it in. I'm just going to go ahead and move this over. And let's go ahead and clear the fractions. So my denominator is 3. I'm going to multiply everything by 3. And we'll go ahead and clear it to begin with. So that gives me 3y. So 3/1 times 2/3 should just give me 2x. 3 times 2 is 6. So now we'll clear the fractions. So now I need to subtract 2x from both sides. And again, I'm going to put it in xy form. So I'm going to put it out front. The 3y is positive. So right now there's x and y are on one side. There's no fractions or decimals, but the x term cannot be negative. This is my x term. This is my coefficient. So to do that, I'm going to multiply everything by -1 or divide everything by -1. That just changes the sign. 2x minus 3y equals 6. Standard form. Okay, so in the last lesson, or one of the last lessons, we've talked about the difference between parallel and perpendicular. Parallel lines have to have slope that is exactly the same. Perpendicular lines have to be opposite signs. and they have to be reciprocals. And again, if they're not parallel and they're not perpendicular, then we consider them neither. So let's look at what we just did with the point slope. And let's look at changing or finding a line that is parallel to this line, but that line passes through point 1, 1. Well, what is first the slope of this line? I don't know, because it's not in slope-intercept form. It has to be in y equals mx plus b. I want it in y equals mx plus b so I can see the slope. So let's do that. Let's solve for y. So I'm going to subtract 5x from both sides. Again, I'm going to put it in the front so it's in a nice form when I finish. Multiply the whole equation by -1. So that gives me... Okay, so now I know the slope of that line. It's 5. So for me to find another line that's parallel to that one, that has the same slope, I've got the slope, and I have my point. This is just what we did before. I need to put it in point slope form. And that kind of tells you I've got a point, I've got a slope. That's my formula. So again, it's y minus, I know in this case my slope is m, x minus, and now I plug in the point that I need. The point that I'm using is 1, 1. It gave me my point. So let's solve for y. Y minus 1 equals 5 times x. 5 times -1 is -5. Add 1 to both sides. I get y equals 5x minus 4. So did I make another line that was parallel to this one? Yep, they have the same slope. But this one you can see goes through a different y-intercept. This one goes through -10. This one goes through -4. So on the graph, they would be parallel. Okay, let's look at one where we have to make it perpendicular. So we've got this line on the graph, and we want to find the line that crosses that line perpendicular, but it goes through point 42. So first we have to find the slope of the original equation. X minus 3y equals 7. So we need it in the form y equals mx plus b so we can see the slope of that line. So I'm going to solve for y. So I'm going to subtract x from both sides. Again, I'm going to put it in the front. Divide everything by -3. Y equals, this is a positive, a negative divided by a negative, so this is 1/3 x. Negative divided by a positive is a negative 7/3. So the slope of the line that I'm trying to be parallel to is 1/3. So my new line should have slope, not parallel, what is this one? We're doing perpendicular. So for a slope to be perpendicular to this, my perpendicular slope would be -3/1 or just -3. So now I have the slope and I have my point. So here's my slope and my point is 4, 2. So now I can use the point slope. So y minus, my slope goes here, x minus, and now I'm going to plug in my point 4, 2. The x goes next to the x, the y goes next to the y. So let's solve for y. -3 times x is -3x. -3 times -4 is a positive 12. Going to add 2 to both sides. My equation in slope-intercept is -3x plus 14. So you can see that these lines should be perpendicular.